Hi, everybody. This is the last section on sequence and series. Two more videos. I broke up this section. 8.3 is geometric sequences and series. The first video will be the geometric sequence material, and the second one will be series. To be honest, it's going to kind of look familiar to the previous one. Some similarities in terms of the types of problems that we're going to do. The difference is a geometric sequence is a sequence where the ratio of consecutive terms is the same. What do I mean by that? Well, if I took, we have some sequence, a sub 1 and then a sub 2 and a sub 3 and so on. If I took consecutive terms a2 divided by a1 or a3 divided by a2, they would be the same ratio. These should be the same. We actually call that ratio R, and you can see we give it the name the common ratio, just kind of like arithmetic was, the common difference. It's a common ratio. Really, what in terms of what does that mean? Well, it means in a geometric sequence we are multiplying or dividing by the same number. If we are dividing, it's going to be the same thing as multiplying by a fraction. So if you're dividing by 2, if you take a sequence, you divide by 2, you're actually multiplying by 1/2. Okay? And the other thing with geometric, they could be positive or negative. So I could be multiplying by -2. Okay? And if I multiply the things by -2, then that'll kind of switch the signs. You'll have a positive, negative, positive, negative. Okay? So some similar types of situations, like the first one, we're just going to find the common ratio. Some of these examples here. So real simple, you just take the consecutive terms and divide them. So if I take 9 over 3, I get 3. So that means my R is 3. If you check, you can see that's what the next one, 27 divided by 9, excuse me, 81 divided by 27, any of those. Or you can just see, hey, I'm multiplying by 3 each time. Okay. So down here, number 2. Again, hopefully you can see that the numbers are doubling. You're going 10, 20, 40, 80, 160. But positive, negative. My R has to be -2 in this case. And again, you could take a term, any two terms, consecutive terms, and divide them to get that answer. Okay, so you can always do that. Which may be something useful in terms of number 3, though some of you might be able to see that I am multiplying by the fraction 1/2, so R is 1/2. But let's say you didn't see that, so you would go 1/8 divided by 1/4. Remember, when you divide a fraction, it's multiplied by the reciprocal, and so this would cancel, and we would get 1/2, and that would be true of any two that you picked. Okay, so a couple things to keep in mind. When R is a whole number, the numbers are going to get larger. Okay, when R is a fraction, or we're dividing by a number, the numbers are going to get smaller. Okay, you can see these are getting smaller, smaller, and smaller. Okay, and we'll even come back to this. A special case here allows us to do something that we couldn't do with arithmetic, and that's towards the end of this whole unit. All right, so the next thing is same thing we kind of did with arithmetic. We need to have a nth term formula. How do we find any term? And there is a pattern the same way there was before. So for example, to find a2, you're going to take a1 times r, whatever the r was. And to find a3, you're going to take a2 times r. Well, we just saw that this is equal to that, so this is a1r times r. And what do we get when we kind of simplify that? We get r squared. Again, kind of like what we did with arithmetic, we're looking for a pattern here. So the fourth term would be a third term, a sub 3, r. Well, this is a sub 3, so a1 r squared times r. And that gives me a1 r cubed. Let's do one more. So the fifth term would be taking the fourth term times r. And this is the fourth term. So a1 r cubed times r is going to give me a1 r to the fourth. So what you're looking for is kind of what we did with arithmetic. We're looking here and here, noticing that the exponent on the r is always one less. So the nth term is a1 r to the n minus 1. And that's your nth term formula. Okay, where n is the term. Okay? All right, so we're going to go back to those 3 examples that we just did, and we're going to come up with the nth term. Now, to do the nth term, we need to know 2 things. We need to know A1, and we need to know R. Well, we said R in this case was 3, and A1 is the first term. That's 3. So this one would look like 3 times 3 to the n minus 1. Okay? Again, the general nth term formula looks like this. All right. I'm going to come back to that one at the end here, but let's do this one here first. So A1 in this case is 10, and R we said was negative 2. So what does that look like? It looks like this. Okay, 10 times negative 2 to the n minus 1. Okay, and I'm going to come back to that one and discuss it as well. So here A1 was 1/4, and we said R was 1/2. So A sub n is 1/4 times 1/2 to the n minus 1. Okay, these are all fine, and we can leave them like that. There's a couple things though I want to talk about with the first one that sometimes you'll see. In this other things, you can't multiply 10 and negative 2. We don't get negative 20 and minus 1. These are not the same, so we can't multiply those things. Okay, now same thing here. 1/4 times 1/2 does not give me 1/8 to the n minus 1. But I can do something with the first one, and the reason I can is because they have the same base. It's like, you know, what's x squared times x cubed? Well, it's x to the 5th. Well, how did we get that? You added the powers. So I can, since these both have the same base, I could add those powers. So another way you might see this answer is 3 to the n, because if I go 1 plus n minus 1, the ones will cancel and you get 3 to the n. Okay? But either way is acceptable to get my answer there, or either form is acceptable for those types of problems. All right. So, you know, what's the benefit of that? Of course, is that we can find the 15th term. So, you know, in the second sequence, this was my nth term, right? And so now that means I could find the 15th, negative 2 of 15 minus 1. So that's 10 times negative 2 to the 14. Do have to be careful here. Again, don't go 10 times negative 2, get negative 20 to the 14th. You know, we can, with these calculators, type it all in one shot. So 10 times, now you would want to put some parentheses around this because of the negative, okay, to the 14th. And we should get 163,840. You're going to get some big numbers with geometric sequences, especially when you have whole numbers for the r's, even positive or negative. If they're fractions, you're going to get pretty small numbers sometimes, okay? All right. So then the last part of this is the trickiest part. And it was the trickiest part with arithmetic as well. It's, you know, how do we come up with nth term, find other terms, find the first 5 if I give you, you know, any 2 terms. For in this case, the second term, you know, a sub 2 is negative 18, and the 5th term, a sub 5, is 2/3. Okay, so how do I find the nth term? A little bit trickier. So this is going to take a little time to go through. So let me kind of go through it first, and then when we're done, I'll say, well, let's look at what we actually did, and let's do that in the future to make life a little easier. All right, so again, if we go back, a sub 5 is a sub 1, r, we'll say 4, because remember it's 5 minus 1, and it equals, in this case, 2/3. Okay, and we know, you know, this is the second term, a sub 1, and that would be r to the first, or just r, equals negative 18. Okay, so how do we go from here? How does this, you know, I'm not going to subtract or do anything like that in terms of what we did previously with the previous problem. So here's how we have to kind of look at this. All right, so we're going to take the larger term, the 5th term. When I mean larger, I mean the actual term. 5th term is larger or is bigger than the second term. Granted, I know that the fifth term is 2/3. It's a smaller number than -18 in terms of the whole numbers. But we're going to take the fifth term. So a1 r to the fourth equals 2/3. Well, what if I broke this up a little bit? a1r, and then this is r cubed. It's 2/3. Well, what is that? a1r. Well, that's right there. And what do we know that's equal to? -18. Okay, again, just go with me here, and then I'm going to cut to the chase. All right, so can we solve that? Yeah, we can divide by -18. Or another way, when you divide by -18, it's the same thing as multiplying by 1 over -18. Okay, so if I do that, I'm going to get -2/54, which reduces to 1 over 20, -1 over 27. I got to take the cube root, and so r is -1/3. Okay? Now, this is the key. The rest of this isn't too bad. But how did we get that? What did we actually end up doing here? Well, if I go back to here, you can kind of see what I did is I kind of divided the top and the bottom. If I divide over here, you subtract powers, right? So you're gonna subtract those powers, and then you're gonna take 2/3 divided by -18, which gives me that answer. So that's what you want to do. That's what I wrote here. So you're going to divide, you're going to divide the numbers, and you're going to subtract the powers, and then you're going to have to take the root of whatever that answer is to get. Now, we still need a1. We can do that easily by actually using this one. So I'm going to go a1 -1/3 equals -18. Multiply by the reciprocal, so multiply by -3. So I get a1 is 54. Okay, so now I do have the first part of the answer I want. The nth term is 54 times -1/3 to the n minus 1. So we wanted that. Last thing we wanted was the sixth term. Well, that's 54 times -1/3 to the fifth, right? Because 6 minus 1 is 5. You can do this all in the calculator, okay? You can get a decimal. I'm totally fine with a decimal on this one. If you work it out kind of fractional, you'll get 54 times -1 over 243, which reduces to -2/9. If you got a decimal in the calculator, 0.2 repeated, -0.2 repeated, okay? So that's the other answer we wanted. So again, a little tricky. So we're going to do one more example, and I'm going to kind of just cut right to the problem to make life a little easier. Okay, so I got the fourth term, and I have the 10th term. So I'm going to start with the 10th term. So a sub 10, well, that would be a1 r to the 9th, right? Because 1 minus equals, and what is our 10th term? 125 over 64. Okay. And then what do we have? The fourth term. Well, that's a1 r to the 3rd, and that equals 125. Okay, so what did I say to do? Well, in a sense, you're taking and dividing these two things. When a1s would cancel, r9 over r3 gives you r6, and this is what I end up with, 125 over 164 divided by 125. Now we gotta, how do I work that? R6, that's 125 over 64 times 1 over 125. Okay, well, cancel, right? And you get 1/64. Take the square root, and r is 1/8. And we still need to figure out, wait a minute, I goofed up. Back up, back up, back up. Somebody else, you probably were screaming at the screen. This should have been a 6, not a 2. You take the 6th root. Again, you can do that in the calculator as well. If you do, you get 1/2. Oops, I'm not sure what happened there. You get 1/2 or 0.5. It can be in a decimal or a fraction. There we go. Sorry about that. All right, so we do need to find the a1. I would probably use the bottom one there of the a fourth term. So I would say a1 and 1/2 to the 3rd equals 125. And that's a1 to the 1/8. Okay, so then I have to multiply both sides by 8, or 8 over 1, so I get 1,000. So my nth term is 1,000, 1/2 to the n minus 1. Okay, I know it didn't ask for the nth term, but there it is. So we do want to know the 14th term. So 14, all right, is 1,000, 1/2 to the 13th. Can do this as a decimal fraction, whatever. Let's try it as a decimal here. So 1,000 times, I'm gonna, no, we can do this. All right, so there's the decimal. We could use the calculator and change it to a fraction. And 125 over 1,024. Either way, I don't care about the answer there in terms of decimals or fraction. Okay, so that would be my 14th term. All right, those two are a little tricky. Look them over again. Try to follow the plan I gave you about subtracting the powers and dividing. Okay, it's the best way to do it. All right, good luck.